Okay, this problem, you might have been tempted to solve this by hand or plug it into a calculator. And if you tried to plug this into your calculator right away, it would not work. And the reason for that is because your calculator is not going to do well with trying to do ln of 5. I'm sorry, 5 to the 400 divided by ln 5. It's too big for a calculator to work on. But you should notice that these two functions are very similar, okay? And you should notice that the bounds are similar as well. So is there a way we can simplify this? So this is 0 to 400 of 5x minus 2 to the x dx. Now, this is 2 to the x minus 5x, but you should remember that if you switch the order, in other words, you multiply by a negative, so we can pull out a negative, okay, and then make it 5 to the x minus 2 to the x. Now, why am I allowed to do this? Well, if you distribute, you get negative 5 to the x minus 2 to the x, right? So then, no big deal. We have the same function now, and now we can combine it. If I go from 0 to 400, okay, so I've got 0 here, 400 here. So this whole area. And then I subtract the area from 1 to 400. So I subtract all of this area. What am I left with? I'm only left with the area from 0 to 1. So I can actually simplify this to be 0 to 1 of 5x minus 2 to the x dx. Okay, so the idea here is use properties of integrals to solve. And then I can find the antiderivative of 5 to the x is 5 to the x over ln of 5. The antiderivative of 2 to the x is 2 to the x over ln of 2. From 0 to 1, plug in 1, you get 5 over ln 5 minus 2 over ln 2. Plug in 0. Okay, 5 to the 0 is 1. 2 to the 0 is 1. And then I believe this was multiple choice where you had answer choices. So you were allowed to, I believe you're allowed to plug in numbers. I'm doing this from memory. You can plug in numbers and, I'm sorry, not plug in numbers. Don't plug in numbers. Plug these numbers into your calculator to solve. Okay, so just figure out what it is, rounded to the nearest 3 decimal places.